Cool. Yeah, so I guess today I want to go over some brief updates that we've been doing on the mesh class inside SimPEG and pulling that out so that it can be used by a couple different people, and also we can look at it and make updates to it sort of in a more granular form. Another thing we're going to talk about today is the massive pull requests that we have waiting to go from dev to master, and so this is also one of the ways that we can maybe mitigate some of those in the future. So I don't know how much there is really to talk about things, and so basically I want you guys to interrupt me and ask questions. What we've decided to call the package coming out of the SimPEG sort of this is encompassing all of the finite volume techniques that were in the SimPEG package. So this is modular with respect to the spatial discretization, so doing 1D, 2D, 3D, doing tensor meshes, regular meshes, logically rectangular non-orthogonal meshes, and cylindrical, as well as tree meshes. So the docs are discretize.simpeg.xyz. Yeah, so there's tensor meshes, there's the cell mesh code, there's the curvilinear mesh, which is rectangular but non-orthogonal, and then the tree mesh as well. So this is again all pretty standard stuff. So not a whole lot has changed since pulling it out, except some cleanup of utilities and namespace and things like that. And actually, pulling it out has shown a couple interdependencies between the solver classes and the meshing classes, and making sure that those are also separated. So I'll talk about some of the solver stuff in the future. So this, again, is the same as SimPEG. So instead of from SimPEG import mesh, you just import discretize, and then you can say discretize.tensorMesh. But for compatibility, we can still do from SimPEG import mesh. Yeah. So basically what I've done inside SimPEG is, and again, this is not a pull request, and I don't think this should go on the current release to master, but for the next one, basically pulling out this mesh stuff, pulling out some of the solver stuff, and leaving from SimPEG import mesh, which will just be basically a symlink to the discretize package. Couple other things, I actually made some work at making the gallery look a little bit nicer using some open source tools. Yeah, hopefully we can add a couple other examples here. Lindsay and I have been working on a bit of explanation around this, and I can share this when it's in a bit better state, but basically going through this, talking about the sort of anatomy of the various cells for the tensor mesh, for this logically rectangular non-orthogonal mesh, so basically a curvilinear mesh where each cell has in 2D 4 neighbors, or in 3D 6 neighbors, but those cells are no longer orthogonal with respect to themselves or the Cartesian axes, as well as the work on the octree stuff, which a bit more about sort of the hanging faces, hanging nodes, and how we deal with that. So hopefully that will come out shortly. Another thing that Lindsay and I did is we wrote a tutorial for the finite volume leading edge, or for the leading edge on finite volume techniques, especially in weak form. So I'll share this when it's in like a slightly better state on the SimPEG drive, and then hopefully we'll publish it somewhere as well. If not, it will be in my thesis. Yeah, so another part of this when I was pulling things out is that for the tests, I needed some access to the solver utilities, but I didn't want to make discretize dependent on SimPEG. I wanted it to sort of be the other way around. So I also spent some time working up the pymatsolver, which just making it sort of, it was split between SimPEG and pymatsolver. So like sort of complicated solvers were in pymatsolver and the simple ones were in SimPEG. So I just sort of put all of them into pymatsolver. Again, this is not actually live inside SimPEG, so SimPEG is still standalone, but now all of that code produced in pymatsolver. So it actually does sort of LU solves, like triangular solves. It wraps some of the SciPy sparse matrices. I think someone wrote a Jacobi solver or a preconditioner in there. Does Paradiso with MKL help. Again, thanks to Dave and Joe for that. And then someone on the internet bugged me about keeping mumps in there, so that's still in there as well. Although the mumps one does not work on pip install, it should work on like into the main repo and just say make mumps or make mumps Mac, and I've left some notes in the README. So hopefully that will help out. I don't know, is there anything?
In terms of Windows?
Oh yeah, I don't know, maybe Joe, you can talk to that about so one of the things that we were trying to do is make the install, especially the pip install, a little bit easier and more tested on both Windows and Linux and Mac machines. So I got the tests up and running on AppFair, which is a testing continuous integration testing platform for Windows, as well as on Travis. And so those are now working after burning about a day and a half of my time. So it should be sort of working on Windows. I had some problems getting the tree mesh stuff working for the Python solver when I was for some of the numbering inside inside Windows. And so I think, Joe, you might have fixed that just now, actually.
Yeah, I had run a few tests, but it was doing something weird. So I'm going to look at it when I get back to my computer at home. Because like I said, I had it working there, and I just made a few changes because I think I remembered what I did. I don't think I caught all of it. So I'll look at it when I get back.
Okay. Have you been using the tree mesh at all?
I mean, I just ran the tests on Windows side, and they all passed when I was building it, SimPEG itself, when it was all one thing. So
yeah. Okay, cool. Yeah, so hopefully even splitting it out gives a bit more attention and visibility to the various pieces inside the finite volume mesh class that we already have working. And we can continue to push on that type of stuff. Cool. I don't know. Anything else about that? So I mean, not a whole lot has changed, but a lot is sort of cleaned up under the hood.
I think it's sort of sometimes it's a hard pymatsolver, and dealing with that is so much painful.
Yeah.
I want to suggest people. And you sit there and then, oh, what's all you have? That's the first question that you ask. So that actually works in Windows, like both mumps and Paradiso?
Mumps, you're gonna have a lot more trouble, but Paradiso should actually work. So what made that really much easier is that Conda actually has, I think Intel like open sourced-ish MKL, and so Conda wrote a wrapper for that and has sort of included it in the base Python distribution that they provide. And so Dave wrote a wrapper for MKL, which Joe fixed, and I wrapped with for Paradiso. So it's.
How about the Python stuff? Because well, I think it's still like if you install SimPEG in Windows, the first warning is that
the interpolation. So I have tested Python, actually the compilation on AppFair, so it works on a Windows machine. I think the problems that we were having were mostly related to the setup .py file, which I did another few iterations on after reading a lot of blogs on the internet. I don't know, Joe, you might have more to say on the structure of that, but I've simplified it a lot. So it should actually be at least transparent what I'm trying to do.
Yeah, the structure that I've used in my setup files was that it kind of follows NumPy's setup as well as SciPy. They have like sub packages, and you kind of leave everything until a later package, and it's just kind of taken care of on its own. It's less in one giant setup.py at the beginning, and it's, like I said, just passed on to individual ones inside each of the sub packages.
Okay. Yeah, and so I think that's also what, especially with breaking out both the solver stuff and the discretize stuff, actually the SimPEG code is pretty simple.
Yeah.
Now, I mean, like there's not actually a whole lot in there other than the structure.
I thought that was the only Python stuff in it was in the mesh.
Yeah.
Yeah.
Yeah. So actually, inside SimPEG now there isn't any Python, and inside pymatsolver that should install. It's actually pure Python. The dependency is on Py, or it's on MKL, which means that you have to use conda, which people should sort of be doing anyways.
Yeah.
So yeah, I think those things have been simplified pretty radically. And basically the only thing that will not work is the interpolation if things.
But it'll still pip install, right?
Yeah, I hope so.
Yeah.
That needs some more testing. I don't have a Windows machine to actually do that on.
Yeah.
And doing it sort of abstractly through AppThere has burned.
If you're testing,
Very time consuming.
then does that mean that?
Sorry?
If you're testing, you said that you're testing Travis like for Windows machine.
No, on AppThere, which is like Travis.
But it runs Windows.
Yeah.
Oh.
Yeah. So it's the Python setup.py is tested on a Windows machine.
Okay, that's good.
Yeah. So that should work. And yeah, I mean, like, obviously people have got it working. I just don't know. I don't know too much about packaging things up in the setup.py stuff. So if anyone else has thoughts there, or Joe, if you have thoughts, do you have a Windows machine, Joe?
Yeah, my PC at home is a Windows, and then I got this Mac machine here. So,
do you think when you get home, especially if you're working on this, could you try just pip install discretize and see what happens?
Yeah, I can do that and see. Sure thing.
Yeah, I have no idea if it will actually work. One of the things another way to do that is using AppThere to create the binary distributions, and then distribute those in the setup, or in the on PyPI.
We should really get Conda Forge going as well for these things.
Yeah.
Because then we get a bit of support from them too.
Oh, really?
Yeah, I think the team's pretty good. From what Leo was saying, they were like quite helpful when he was getting Fernando. Okay. Have you done that, Joe?
I haven't used Conda Forge, but I have made wheel files, which are the new version of whatever eggs that Python used to use. So when you see things like installing wheels on the Linux side, they do that. It's just everything's pre-built, so it just comes right to the machine. So they don't have to mess around with any compilers, which you guys always have to have those issues on Windows of installing the right C compiler and everything.
Yeah.
Yeah, so that's sort of an overview of where I've been sinking some time into just basically cleaning up the underlying stuff inside SimPEG so that it can be used a bit more widely. I think breaking out the finite volume stuff is pretty helpful.
Yeah, so then I guess like for people, future development, make issues there.
Yeah.
I think you do something on SimPEG, like we'll figure it out, but
Yeah.
Yeah.
And then did you want to go over the dev pull request at all?
Yes.
Briefly, or just
Briefly.
say that we should deal with it?
We need to deal with it. Yeah, so I think that having broken out discretize, even though like I don't actually think there's too much code that touches it, it'll help hopefully trim this down. I would perhaps like to see us doing pulls from dev to master a little more often, because this is 12,000, close to 13,000 lines of code, which is insane. Like I am not capable of doing a decent review on that. But that said, we need to get it in, and I think we need to get it in soon. And why that's important, especially now, is because the disk is coming up, and we are going to be distributing SimPEG code and like pointing people to SimPEG, so we need to have it up to date. So I guess the thing that I would ask is that just like take a skim through. If there's stuff that you touched that is in that process, just document it. Because I think the thing to do is basically get this in. Like I think we should change the depreciation, get rid of that, or depreciate.py.
Yep.
And then once that's gone, let's just get it in, and we'll do some quick cleanup in the next couple of weeks. Yeah, to get it sort of up to snuff.
Yeah, so I think, yeah, the biggest things that we changed were mapping. We've broken this out into multiple mappings, and so they're actually explicitly named. So that would be the biggest breaking of backwards compatibility, and then small changes like cur model is now actually model, and then under the hood there, a lot has actually changed about how we're representing that, especially using properties.
And the mappings should error, like when you use mapping equals whatever, it should error in a very nice, very clear way. So it'll say use sigma map or whatever. It'll be a little bit of a pain point, but hopefully not too bad. I think most people have been working off dev anyways.
Yeah.
Just keep that open.
Oh yeah, fair enough.
That's the thing that she's today.
Yeah.
Cool.
Can you pull up the EM notebooks docs?
Oh yeah, there's.
This is like very EM dash notebooks.
EM dash?
EM here's one.
It's probably in here somewhere.
So right now this is only one notebook. But with the discourse coming up, there's sort of two distributions that we are doing of code. One is the EM examples that is currently under the UBC GIF organization. And that's all the apps. And then the other thing I would like to see is like a handful of examples that we consider to be like a good programmatic use of SimPEG, so that people can actually get up and running, in particular with the EM code, because that's what the course is about. So this is just a simple example. Definitely needs like a little more documentation. This is the Silmesh. Yeah, so if you guys have comments on that, that would be great. The docs for this I'm really excited about, because it's EM dash notebooks. Yeah, I'll get it under the SimPEG. This page is built entirely from the notebook, which is slick. So there's a few things to like clean up. If you follow that edit on GitHub link, it won't take you anywhere right now. But it automatically, yeah, it runs your notebook, prints out all the plots and all the lines of code and stuff. So it's nice.
Yeah,
That's great code.
Cool. Yeah, and then maybe other minor things that I've been pushing on mainly because of my thesis is some equations, I'm sort of breaking those out so that I'm putting them into an equation bank similar to how we're doing on the EM
That's actually nice.
GeoSci, so that we can use these things
That's very good.
in a more reusable way. And then also doing that with, well, so that we can sort of see both the captions and the actual picture.
Oh, that's very nice.
And so I'll put some of the source code for this in terms of, I use Illustrator, which might not be helpful to people who don't have Illustrator.
Okay.
But yeah, so these, that should be helpful, hopefully. And then hopefully those can be used across sort of the various places that we, like these notebooks and the documentation and PCs and all of that stuff. Yeah, so a couple random things there. So yeah, discretize, figures, equations, EM notebooks, SimPEG dev. I guess that's the
That's the things.
those are the things that happened in the last couple weeks.
Yeah.
Very nice.
Yeah.
Absolutely.
Yeah. I would like to perhaps put a deadline on the dev to master pull request. The end of this week. Is that reasonable?
Yeah, I think so.
Okay. So it'll, yeah. Well, if everybody can just take a quick look at comments.
Yes, especially Sagi, I appreciate your view on the DC IP stuff, and then maybe Don, if you're listening.
Also, like you want to edit this like weekly types of.
Just the pull request notes.
Oh, I see.
Yeah,
Yeah.
just the notes, and even if you just like do a review and say what, basically high level what was added, especially on the DC side of things, and what's working in your opinion, and especially what's not.
Yeah.
That would be super helpful.
Yeah, and then the last thing, Joe, we are going to be in Denver on the 30th. So the disc is going to be on the 30th, and then we will be there for basically 2 days doing like disc related stuff. So day 1 will be the course, and then day 2 will be around chatting, hopefully working with you guys. I would really enjoy catching up and doing some stuff. So
Actually, another
Who's all
thing.
coming down?
Sorry?
Who's coming down?
it'll be myself, Sagi, and Doug.
Okay.
Yeah, yeah.
Is that
It's not very
disappointment to you?
Oh, it's not everybody.
Yeah.
And Joe, another thing that I've been sort of pushing on is a big refactor on the Richards equation stuff. And so that's actually a lot cleaner. And in terms of, you can now invert for any physical property, and it actually makes sense. Before I was sort of like baking in concepts of log conductivity, and that's been fixed. And actually, Sagi, you might be interested in the way that I'm functional models for like nonlinearity or like dependence, in your case in IP, on frequency. Mine is dependent on the fields.
Yeah, your case is much nonlinear.
Yeah.
Mine's actually like fine.
Yeah.
It's not interacting with the field,
Yeah.
so.
But it might, like the way that I structured it might be helpful for you, so I can go through that at some point if you're interested.
Yeah.
But yeah, Joe, if you're at all interested in the Richards equation stuff, it actually is, and there's a couple examples. I think it's on like refactor flow branch.
Yeah, I'll check it out.
Refactor flow.
Or ref/flow or something like that. Cool.
Yeah, is there anything else you guys want
Joe, any updates from you?
Not too much really. Just working on my iPad all over break and working on my notes and being like, okay, I gotta figure out the derivative of a matrix times a vector, where the matrix has the like the derivative of the matrix itself times an arbitrary vector, and then the operation of that on a vector, because it doesn't really make sense to form that matrix itself.
Yeah.
It was weird.
Um,
It's a lot of work for something that's zero most of the time.
Are you planning like a kind of restructuring optimization? Well, I think I think it works as a first order way.
Yes.
But as I'm using through, there are, I think it's not a problem to code, but that's just how we're dealing with the problem. So.
Well, and the code is dense.
Yeah, that's sort of fine, but
Yeah, I think maybe order of operations. There's some. I think the composable objective function work that Lindsay's doing is probably a first step to that. In that we've been sort of renaming and restructuring how we're accessing derivatives and second derivatives. And that's one of the big things in the optimization code, that it's sort of the way that you interact with it. It gets all three of the function evaluation, the gradient, and the Hessian at once, which is a little bit different than most optimization packages, especially SciPy, is they actually say that you should get those separately. And so that's like one of the ways that we can start to go in that direction, is just changing up that interface so that we can at least use external optimization packages is probably actually better than wrapping our own entirely.
Yeah, I'm not sure.
I'm also not sure.
It's very subtle, and it's
Yeah.
sort of state of art, and then it's very dependent on the problem
Yeah.
side. So using like just a SciPy optimization package is sort of dangerous.
Yeah. I think I like at least the option, especially on like some of the easier ones. I also am not sure what happens when you go in around with all of the various parameters and change things as you're like moving in the inversion. Which is what we do through the directives. But yeah, so I think that's like farther down, but has been on the list for at least 2 years.
And other comments was I got an email from seismic guy. Well, he's a student. And
Okay.
what he asked was like, so he looked through the EM code, potential field code, and stuff, and what he found out, the field class is very different. So like, trying to write the seismic code, for instance, like acoustic or modeling. And he was asking what should I do for it? Like, and also survey is very different. Like,
between the various packages.
yeah, between the various like prompts. So I was asking like, what should I follow? I didn't know the answer, so you should figure it out. That was my answer. But so yeah, I think it's probably. And then he's from like pretty serious group. So they're doing large scale seismic.
Which group?
It's Korean university,
Okay.
but they're like relatively famous for a full version.
Okay.
But I think it's starting for modeling. But that's probably a good place to start in just having a good formal code.
Yeah.
And then I think he knows probably like all this knowledge about how they're doing.
Yeah.
Yeah, but I think current field class, I don't know how well, like how good it is to handle large scale, like for instance, I'm not sure. For instance, I'm pretty sure Brandon may not use the field.
No, I think. No, I don't think he has. Yeah, I mean, I would say that the EM structure is probably the best to follow. It's also the most complicated.
Yeah, and fields and surveys. So that was
the fields and the surveys. I mean, yeah, I would say
The survey for EM is in reasonably good shape. For frequency domain, it's pretty minimal though. We don't actually have much there. But like in terms of having sources as classes, actually the time domain code for the survey, there's not a whole lot there, but I think it's in reasonably good shape.
Yeah.
Because that we've separated out, which could be quite useful for Zymic, we've separated out the waveform from the source.
Yes.
And you pair those things.
Right.
So like those kinds of ideas are actually still like in a reasonably simple form because it hasn't grown too much yet.
That's true.
One of the things we do need to do is remove the dependence of the fields object on the survey. The fields should take a.
Just a problem.
Yeah.
Yeah.
But that's.
My point was getting attention.
Yeah.
Yeah. They can figure out what is the best way.
Yeah.
For their problem.
Yeah, but where to look.
Yeah,
I think EM is probably.
Because I think seismic and GPR is relatively big problem. So
Yeah.
You need a different philosophy to solve the problem.
Yes.
So, I mean, we haven't like quite thought about that.
Yeah.
Well, we've thought about that, but not seriously. So that would be.
Yeah.
Yeah, I would point him to Zephyr as well. Some of Brendan's work.
Yeah.
And I think like we've started building towards ideas of like checkpointing and things like that in the fields object. None of that is implemented, but like I don't know, we've thought about it a little bit. So I mean that could be something like we could have a conversation with him too about.
Yeah, I think that would probably be the
Yeah.
Best.
I let him know like the slides.
Yeah.
Yeah.
Probably actually see what they're doing.
Yeah.
I don't know him, so probably need him on that.
That's exciting.
Oh, and then the HEU presentation was pretty good.
Oh, good. That's
Sorry.
exciting. Cool.
Did the AGU put things on using kind of a sci-fi like YouTube video of the conference?
Yeah.
No, it's a poster.
Yeah.
Okay.
I think like invited talk or like keynote talk, probably.
Yeah.
Okay.
You're on Facebook. I don't know why.
Yeah.
Anyways. You can't access them. Cool. Any other things? Okay.
Not right now.
Fair enough.
Excellent. Okay. Cool.
Perfect.
We'll talk to you later then. I guess
Yeah.
Lindsay and Soggy will be down in a few days.
Yeah. Dude,
15.
Yeah.
Don't say that.
I'll send you an email with some of the stuff that we are up to for.
Okay. We have time to bring your skis?
And maybe we'll see. That would be good. Is it snow right now?
Oh yeah.
Yeah.
There's snow everywhere. It's a little warm today, but there's a lot of snow in the mountains. One of the mountains had to close down because of too much snow.
Oh wow. Okay, that's a good problem. Cool. All right. Well, thanks for joining, Joe. We will see you later.
See you guys.
Bye, Joe.
Bye.